Okay, guys, let's go. Welcome to Ice Education. Okay, yes, we can. Okay, Andile, without wasting time, I think you wanted to do question three, so we gotta do it. Where's the sniping tool? Sniping tool. A question like this came today. Okay, Andile, this is question about beam. What was the question about again? There's something about you that's wanna make me lose my. Okay. It says the beam in figure Q2 is statically and indeterminate and discretized in two elements. Calculate the global thickness, the global stiffness matrix, okay, which is 10 mark, cause yeah, and then the displacement at node 1. Okay. Okay, global stiffness matrix. And the global stiffness matrix is K. Okay, remember in this spring thing that we are doing here, for each cases you do have how can I say, for each cases you do have how to get the global stiffness, the way to get it. In case of beam, here's the general formula from this Excel sheet. Here is the general formula of beam. It says K is E12 what, and remember this formula will be provided. Let me oh, Mr. Kambamba just joined. Kabamba. Kambamba. Mr. Kabamba, your name sounds like Kambata. It's like you guys
Yeah, I'm from the
Kambata. Mr. Abubakar, do you also have a name like Kabungu, Kabutu, Kambata? Those nice Congolese names. Kalongo.
so they are nice, no?
Yeah. Man, those are Congolese names. Are they not nice, my brother? Okay, Andile, for the sake of being
They are
relatively
powerful.
in case of beam, this is how you get your K for each element. Now, this is the thing that I said last time. Whenever you are doing these things, first thing to do, you count the number of nodes that you have. How many nodes do you have? You have one, two, three. How many elements do you have? Between two nodes, you have one element. Like from 1 to 2, I have element 1. From 2 to 3, I have element 2. So I do have 2 element. So for element 1, I will call it K1. What is K1? It is AI over L cube. What is E? E is given. You can see here. So what you do is you'll have for element 1, you will have 2, 1, 10, 10 to 9 and delay multiply by I is 4, 10 to minus 5, everything divided by L cube. What is the L between element and 1 and 2? It is 6, so it's gonna be 6 cube. Now you do copy the formula. The formula says we have 12, which is 12. We have 6L. 6L will be 6 by 6, which is 36. We are following the formula. We have minus 12, and we also have 612, which is 36. We move down, Mr. Kambata, 6L, 36. This is 4L square. So what you do is You type 4 multiplied by 36 square. What is the answer? I mean, no, multiply by 6 square. Let me not say 36 square. 6 square gives 36. 36 by 4 should give 144. This is how we fill this table, guys. Minus 6L. So minus 36. This one is 2L square. So 2 times 36, it is 72. What else do we have? We have minus 12. This is the formula that we just follow. Minus 6L, it gives minus 36, 6 by 6. We have 12 minus 6L. This one gives minus 36. It seems like this equation kind of repeats itself. Like if you look at it, it's more or less of a game. 6L here is 36. 2L square is 72. Minus 6L is minus 36. This one will have minus 144. Okay, it is important to notice, Andile, when you have a beam, for each element you have a V, which is the force, V1, and then phi 1, which is the angle at which this thing is bending when there is an effect of, how can I say it, when a bending is being applied or a force being applied create a bending. So for element 1 you have V1. Okay, let me show you the formula to see what I'm talking about. For each element, like for instance here, you do have V1 phi 1, V2 phi 1, where V stands for the force and phi stands for the angle. What do I mean by that? The force simply means here that you see this thing apply here is the force. As you apply the force, this thing will bend through a certain angle that creates a moment. That's what we are studying. That's why we have, for each element we have V1 and phi 1, force and angle. So this one is V2 and phi 2. Now you have here as well V1. We do have here phi 1. We do have V2. We do have phi 2. So we've written K1 for element 1. So for element 2, we can call it K2. But as you can see, element 1 and 2, they are the same here. Do you guys agree? Because the distance between 2 and 3 is 6, which is 6 here. They also have the same E and the same I. So nothing is really changing. What is changing, it's simply here is going to be between V2 and V3. I don't know if I'm making sense. But everything here, starting, escape. Starting from this one to this one, Control C. Let me put it down here. Control V. It's the same, guys. Only thing changing here, this one will be between V2 phi 2 and then V3 phi 3. V2 and then V3 phi 3. Now if you look on my YouTube channel for a couple of examples that we've done about this topic, guys, I say the most important thing is how to get the global stiffness. But for you to get the global stiffness, you need to expand. Now it is important to know, how are you going to expand? I said the number of node gives you the type of matrix that you should expect by expanding. What do I mean by that? If I count 3 nodes, 1, 2, 3, it means I'm going to have a 3 by 3 matrix. But now, we cannot have a 3 by 3. Why? Because each element is having V and phi. So it means the number of nodes that you have, you need to multiply it by 2. So it means you are going to have a 6 by 6 matrix. Let me repeat myself again. You count the number of nodes that you have. 1, 2, 3. Therefore, this means that I have a 3 by 3. But I cannot have a 3 by 3 in this case because each element is having, can I say, two direction? Two direction is a bit out of what I mean. But each, how can I say it? Each node is having two component. Yeah, that one makes sense. Each node is having two component. So it means that uh, instead of when you gonna have a 3 by 3, you need to multiply it by 2 because each node is having two elements. So which means the matrix that we're going to expand here will be a 6 by 6. To explain it clearly, let's look at the example that the lecturer did. Under this case, if we count the node, how much do we have, Mr. Kabamba? 1, 2, 3, 4, 5. This means that we are expecting a 5 by 5. Because it is a beam and it is having two components, therefore everything here, the 5 here should be multiplied by 2, which gives a 10 by 10. That's one of the reasons you see a 10 by 10 matrices here. This is applicable for this case. It is also applicable when we are studying stiffness matrix where we have two elements in x and y moving on the x and y axis. The only reason why we multiply by 2 it is because they have two components in each node. Andy, are you with me? Let me see if we're still together here. Yes. Hey, Mr. Abubakar, my brother, you're not talking today. It seems like.
It's nice. How's it been? How's it? No, I'm okay, my brother. I'm following.
Oh, okay, my brother. I thought maybe Xavier did you bad and you don't want to speak to me.
No, it's fine, man.
Okay, Andy Leshangwe. So this has to be a 6 by 6. So how do we expand to a 6 by 6? We can do it once, or what you can do, you can expand each
Yeah, you see,
matrix.
my new girlfriend is there, so I don't want to talk much.
Which one?
Andile.
Brother, don't make jokes like that. Andy's boyfriend will look for you in the val. Well, don't play with fire. It's December. You don't play with people's women here in South Africa. They will kill you. Hey. Okay. Ah, here we go. Andile, you can expand this thing like K1, you expand it, K2, you expand, and then you add. Yeah, this method will work for this short thing like this. It's fine. But when you have, let's say, 8 by 8, it's going to take you long. But if we have to do it once, Andile, this is how we do, how we write the global stiffness here, guys. We have total K for not say for saying global stiffness. Okay, whatever you will calculate here, remember these two are the same. The value here and here is the same. What's the value? If you calculate this until what's the answer? Sorry, guys. So if you calculate this one, how much do you get, guys? 2 what? Okay, guys, since you don't want to calculate and delay, I'm calling this answer to be alpha. You'll give me the answer afterward. Okay, alpha, it is the answer here. You guys don't want to calculate, so I don't have a choice. So we have V1, we have phi 1, it is phi, it's not Q. We have V2, that's what makes it 6 by 6. Phi 2, we have V3, phi 3, V1, phi 1. Oh, why is my voice blocking? Okay, Andile, to get the global stiffness, we can do it for each element. What do I mean by that? We look at V1. You have V1 here and V1 here. Do you have any other V1 in the second element? No. So when you look at V1, it is 12. So V1, you copy the number that is here, 12. You go to phi 1. You have we have phi 1, Mr. Andile. Mr. Abubakar. My eyes are hurting, Mr. Abubakar. Very bad. I don't know why. Oh, I left my glasses. Okay, Mr. Abubakar, we have phi 1. Phi 1 is 36. Do we have any other phi 1? Phi 1 and phi 1. Wait, am I mistaken something here? Let me check here. Let's say phi 1. Phi 1 is 6L. Do I have another phi 1? No. 6L. V2 minus 12. Do I have another V2 here? V2 minus 12. V2. How do we do it once again? Mr. Abubakar, how do we do it once? Ooh, I thought my thing disappeared there.
Mr. Ice, my brother, what are you saying?
Yeah, I was saying, how do we do it once again, my brother? Last time on my YouTube channel, I did it once.
Yeah, isn't it's you have to go there and check V1 where it like V1 and V1.
V1 is 12.
Then you have
Phi 1.
yeah, fixed one and V1. Yeah, and V1.
Okay, yeah.
So it's 36 there.
Phi 1, V1. Yes, thank you. Thank you for that. Phi 1, V1. What do you have? 36. Thank you, my brother. V2 and V1. V2, V1. What's the value? Minus 12. Phi 2 and V1. Phi 2 and V1. What's the value? 36. Now, you don't have anything between V3 and V1. You don't have it here. So it means this side should be 0, 0. You move again, Andy. That's the global stiffness. We go to the second element. V1 and phi 1 down here. What's the value? V1 phi 1. So V1 phi 1, the value is 36. So this one is 36. Phi 1 and phi 1. What's the value? 144. Now let's go V2 and phi 1. V2 phi 1. What's the value? Minus 36. Phi 2 and phi 1. Phi 2 phi 1. Phi 2 phi 1. You check the value, 72. Do you have any relation between V3 and 1? No. So this one is 0, 0. We move to the second one now. We go V1, V2. V1, V2. What is the value? V1, V2 gives minus 12. So this one is minus 12. And delay. Phi 1, V2. Phi 1, V2 gives minus 36. Now, V2 and V2 here. V2 gives 12. V2 gives 12. Now, what else do we have? This is V2. Phi 2, V2. Phi 2, V2. Phi 2, V2 gives minus 36. Now we have V3, V2. Do we have V3, V2 here? My eyes. Guys, you guys don't wanna pay. I'm even crying in front of the screen. That's bad. But it's okay. Next it is V3. Wait, I think I'm mistaken something, Mr. Bubakar. Why am I not taking in consideration this second element here? Let me erase here. Let's redo the third line. The first line is fine because there is no any V1 on the second here. But now we have to be careful when it comes to V2. When we look at V1, V2, what's the value? V1, V2 is this one. Do we have any V1, V2 here? No. V1, V2 is minus 12. So it's minus 12. Phi 1, V2. Do we have any phi 1, V2 here? No, we do not. So therefore, this is phi 1, V2 is minus 36. V2, you have to be careful when you do this. It requires attention. V2, V2, V2. V2, V2 gives 12. Do we also have V2, V2 here? So Bubakar, speak, my brother. Speak to me, please.
Yes.
Yes.
I just want to double check something here.
Double check.
What I'm doing.
So Bubakar, double check.
Yeah, it's like we are doing right. I don't know.
Yeah, let's go. Let's continue.
Yeah, we are going right. Remember where like stuff are like the same, you have to add them.
Yeah, that's what I'm checking here.
Oh.
This one here,
Yeah,
we
so
are
far you
between.
just have to double check. Like you see, like this one you have phi 2 and V2. This side you have something like phi 2 and V2. Then you have to add them. So,
This one
yeah,
is
but
V2,
so
V2,
far
V2,
V2 V2. Is there any V2? Yeah, there's a V2 V2. So you have to add them.
There's a V2, also a V2 here.
Yeah, so you need to add, isn't?
Nah, the adding has to make sense. They have to fall under the same line. Let me check here. Let's check the adding of 12 and 12 here.
They have to fall under the same line.
Yeah, let's follow the adding of 12
Yeah.
and 12 here. This one is between
12 and 12. Yeah.
and phi 2, right?
Yeah, V2 and phi 2. Yeah.
Okay, let's check. This is
And
V2. This is
Yeah.
V2. This
Yeah.
is phi 2.
That one is phi 2.
Now, do you have any
No,
V2?
remember, no, this is between V2 and V2, Mr. Ice.
This
Is it phi 2?
V2?
No, it's V2 because it's 1, 2, 3. Yeah, 1, 2.
Okay, yeah. This is
yeah,
between
1, 2, 3 is V2.
V2 and V2. It is 12.
And V2, yeah, there's
Do
a
you
12
have
there.
another V2?
Then if you check,
V2. Yes, 12.
yeah, there's a 12 there.
So that's why it
V2
is
and
12
V2,
plus
there's
12.
Yeah.
Oh, yeah. Okay, it's fine. So here, V2 gives 12. We also have a V2. So it's going to be 12 plus 12, which gives 24. Phi 2 and delay V2. It is minus 36. We also have phi 2 V2. So it's going to be minus 36 plus 36. It's giving 0. We move to V3, V2. Do we have any V3, V2? Yes, it is minus 12.
Mr. Hayes.
Huh?
No. From there already. I don't. Okay. Let me double check this thing.
Guys, if this thing is giving Shaile a hard time, let's expand it. Let's expand it, Andy.
No. You want to expand it?
Yeah, my brother, if it's giving hard time,
There-
why
There's,
not doing a method that...
there's no need of expanding because, like, it's straightforward there. You can see that there should be supposed to be 0, 0.
it
understand?
can't be 0, my brother. Now you are between V3 and V2.
You're right. You are right. No, you are
Minus
right.
12.
No, you are right. You are right.
Now we have phi 3 and V2. Phi 3 and V2
You are right.
is
Sorry.
36. Now it's fine, my brother. We are trying to get a better way of doing this so that we all understand. Now we move again, Mr. Bobakar, to the following point, which is what? We are between V1 and phi 2. Yeah, V1, phi 2. We are between V1 and phi 2. V1 phi 2 is 36. So this side here is 36 because you only have only one V1 phi. Phi 1 phi 2. Phi 1 phi 2 is 72. Now we have to pay attention here. V2 phi 2 is minus 36. Do we have any other V2 phi 2? Yes, it is 36. So you're going to have minus 36 plus the 36 here, which gives 0. Now, phi 2... why am I saying? Sorry, guys. Phi 2, minus 144. Do you have again phi 2 here? Yes, it is 72. So it means you're going to have minus 144 plus 72.
No, it's 40. No, Mr. Ice. Phi 2 is 144. That one is phi 3. The 72 is phi 3.
My eyes, my bad. I'm telling you that I'm crying in front of the screen. That's bad. I left my glasses. Okay, Mr. Wawaka. We have phi 2 is 144. Right? Phi 2 here is minus 44. If you add the 2, it gives 0. That's what's happening. I'm going to double check it by expanding. The following one is what? V3 phi 2. V3 phi 2 is minus 36. Oh, minus 36. Phi 3. Where is it again? Phi 3, phi 2 is 72. Phi 2, the value is 72. So this side is 72. Okay, Mr. Bobakar, after doing that, what do we do now? We move between V2 and V3 now. This is kind of straight, but I don't know why is it getting confusing, guys. My eyes.
But remember, so far, V1, V3 is going to be 0. Then
Yeah,
phi 1,
there will be 0.
V3 is... Yeah. Then we have V2, V3, which is minus 12.
So now, what's happening here? We don't have any relationship between this is between V2 and V3. Only this side is taken in consideration. Between V2 and V3. So confidently where there is V1, I can put them 0. I can write them 0 confidently. That's what it means. It's just like what happened here. When you are dealing between V1 and V2, everything here add values, but this side was 0. Now I'm dealing between V2 and V3. Everything will have values coming here going down, but this 2 here will be 0. So our focus is here. When we have V2, V3, what is the value, Mr. Bobaka? V2, V3. V2, V3 is minus 12. You also have, no, we don't have it here. So it's not going to add there. V2, V3 will be minus 12. You come, you write minus 12. What else do we do? We go V2 now again.
Then fight 2, is it fight 2 V3?
Oh, Mr. Bakar, we finished first one, and what do? Remember for this one, we did V1, V1, we did V1, V1, we did Phi 1, V1.
Phi 1 V1. Yeah.
Now,
No, that is same thing. I'm not saying after V2 there is Phi 2.
Yeah, it is Phi 2.
So it's going to be Phi 2
Phi
and
2 V3. Phi 2.
Yeah, which is minus
the value?
36.
Minus 36. Next, it is V2. Is it V2?
V2 V3.
V3 V3.
Yeah, V3 V3. Sorry.
It's 12.
12.
Is the value. You just have to see. Please, when doing this guy, please be careful. Please pay attention. And now we have Phi 3 V3. It is minus 36. Phi 3 V3 minus 36. Now we move up again. Last one, Andile. We have V1, V2, Phi 3, 36. V2, Phi 3, 36. It's bad for me right now.
Sorry.
Phi 2, Phi 3. Phi 2, Phi 3 is 72. V3, Phi 3. You just have to look. V3, Phi 3. What's the value? Minus 36. So therefore,
minus 36.
Now you see Phi 3, Phi 3, minus 144. So this is minus 144. And lie with me. You can do it like that, or if like this, if you're not confident enough, you can expand. By expanding, I mean you can write U1, V1 for each element. U2, no, not V, it is Phi. Sorry, guys. You go V, they are V actually, I'm sorry. They are V's. Now, by expanding, it means you fulfill this guy the way they are. You have, so this one here is also V1, Phi 1. This one is V2, Phi 2. This one is V3, Phi 3. This one is kind of long, but it's safe. Now, what's happening, guys? If you want to expand like this, what you do, Andile, you copy this guy the way they are. Remember, you have here 12. You just copy. Remember, it's between U1 and V2. You just copy now. You go 12, 36, minus 12, 36. This is the expanding method. This one is 36. You copy everything the way it is, without thinking even. As long as it falls under the guys that you took there. This is the expanding method. Yo, this laptop is crying. Like, ooh. So what's happening now? Wherever now you don't have V2 and U3, you just add zeros. This is how you do the expanding method. Now we do the same thing. We expand for K2 and delay. This is if you want to play safe. If the matrix is small, like this one, please play safe. Play safe and get it right. You still have V1, phi 1. You have V2, phi 2. You have V3, phi 3. Let me move it up again, sorry. This can go down. Everything coming here. V1, phi 1. V2, phi 2. V3, phi 3. Now, this is what's happening, Mr. Abubakar. When we have V1, okay, let me Andile, we are expanding, so we are between the second matrix here. So you are between V2 and V3. You copy all the guys the way they are. That's what it means. You come here, you copy them the way they are. You don't think. 12, 36. Expanding is less thinking, and it might be long, but it's fine. I think it's fine. But it's better to do it when you have 6 by 6. But when you have a 10 by 10, if you have to expand each and every element, that will take you time for sure. But I don't think Rosa will give you a 10 by 10 in the exam. He's not gonna give you something like that. Oh, I think I might have expanded also. I think I did not expand it well. This thing here, sorry, these values here, they stop at phi 2. From V3 phi 3, everything here is 0. Let me do it right so that let me do it right. Mr. Bobakar, let me do it right. Andy, lie with me. I was adding the 0. The 0 is here. Let me erase here, because it has to make sense. The 0 is here. It is V2 phi 2. Now V3 phi 3, where there is V3 phi 3 here, because you don't have anything, it is also 0, 0, 0, 0, 0. What you want to see when you expand is what you have here. That's what we do. Yeah, let me write it in the way that it is making sense, so that when we add, we see where we are. So for K2, we are expanding again. I call that one alpha, the value there, because we did not want to use our calculator. I don't know for what reason, but it is what it is. That one, that there. Okay, here we go. We have V1 phi 1, V2 phi 2, V3 phi 3. Yeah, that's the thing. Now guys, what do? We fill the guys between V2 and V3. V2, remember, the matrix 2 is between V2 V2 phi 2 and V3 phi 3. So what you do is you have V2 phi 2, V3 phi 2. You also have V2 phi 2, V3 phi 2. So it's gonna be along this area here. So what do I mean by that? Where there is V1 here, you can confidently put them 0. Confidently do that, because what you have values between V2s and this guy. Now from here, what do? Remember, we have V1 and phi 1 here. We can also continue, because that's what the expanding method is. What you don't have there, you just add the 0. So the remaining space allocated to you, you copy your guy the way it is. The expanding method might be long, but is safe. Either way, both methods are fine. You just need to get one that you're comfortable, but get comfortable with this one. In this case, even if the matrix is a 10 by 10, you can defend yourself. Shit, I feel like. And this one is 3672 minus 36 minus 144. So Andile, this is it. If you want to find the global stiffness, what do? Now you add K1 and K2. Now what's happening is you will take 12 plus 12, it gives 12. That's what we did when we were doing it straight. That's why you get 12 on the global stiffness. You are basically adding each element. Let me zoom it out a bit so that we can see. If we have 36 and 0, that's what it gives 36. That's basically what's happening when you add. If you have V2 and this one, you add V2 and this one, it gives you minus 12. You add 36 and 0, it gives you 36. It gives 0, 0. That's what we got here, that we did directly. I hope you are with me. This the direct method is the expanding. So you add these two to get the global stiffness. Now we have 36. This one, 36 plus 0 is 0. 144 plus 0 is 144. Minus 36 plus 0 is minus 36. 72 plus 0 is 72. The rest is 0, 0. Now you come to the third line. Minus 12 plus 0 is minus 12. Minus 36 plus 0 is minus 36. What is going on there? Where's the third line again? Yeah. 12 plus 12. That's what gives 24 here. Now, here we go. What is the next element? Minus 36 plus 36. That's what gives 0 here. So basically what we did, this was the direct method, but this, if you do it by expanding, you have to get the same thing. You can check again here. Now you have 0 minus 12. That's why you have minus 12. 0 plus 36. That's why it is 36. And we move again, Andile. We have 36 plus 0, which gives 36. 72 plus 0, which gives 72. Minus 36 plus 36, which were giving 0. Minus 144 plus 144, which was giving 0 also here. Minus 36 plus 0 is minus 36. 72 plus 0 is 72. You do it for each and every element. You add them. 0 plus 0 gives 0. 0 plus 0 gives 0. 0 minus 12. That's why we have minus 12. 0 minus 36. That's why we have minus 36. 0, 12. That's why we have 12. 0 minus 36. That's why we have minus 36. 0 plus 0 is 0. 0 plus 0 is 0. 0 plus 36 gives 36. 0 plus 72 gives 72. 0 minus 36 give minus 36. 0 minus 144 give minus 144. So you have both way of doing it. If doing it straight is better, it saves you more time. But expanding just gives you the way to double check. Sorry guys, I just want to blow my nose. Sorry. Yes. So Andile, if we do that, we have answered question 1. Question 1 was to find the global stiffness. Question 2, this is the global stiffness. That's what they mean by that. Question 2, Andile, what was it again? Oh. Displacement at node 1. Ooh. How do we solve the displacement at node 1? Where is node 1 again? You look at your picture here. Sorry, you have node 1 is the first one here. This is node 1. They want to find the displacement at node 1. But remember, I said when you have a cantilever, this is more or less like a fixed point. The displacement along this is 0. At 2 here, because it is a support point, the displacement along 2 years is also 0. That's one of the reasons why they only ask you to get the displacement along here. Now remember, these things here, we are dealing with global stiffness. You can go with the logics of physics. What do I mean by that? You do know that force is equal to K times X. Do you know that from theory of machine that you wrote today? You know that force is equal to spring times displacement. So now, how do we apply this here, Andile? We do have a let me check here. Let me check the global stiffness. What was the question here again? Fix determine the nodal displacement rotational. Okay, what do that mean? The nodal displacement of the force. This is the whatever there. This is the global matrix. So by nodal displacement, what do they mean by that? I just want to check what do they mean by that. What happened? Ooh. What happened? What happened? There's something about you. That's wanna make me go about you. Something about you. There's something about you. Mr. Mashau Junior. How's it, my brother? Today people are tired. They say vibration was hectic. They want to rest. What? Was it also hectic for you, my brother? V5. Away, relay. Rotation at node symmetric. Okay, my brother. Let's just give this guy 2 minutes to join. Oh, no. Where the- Mr. Marshall, unfortunately, people say they are tired today because of I don't know what happened. Was it vibration? How was it for you, my brother?
No, I didn't write today.
Oh, okay, okay, no problem.
Yeah.
I
So
thought it was hectic. Now, what you gonna do? You guys are watching on Friday. Is it Friday?
on Thursday.
Yeah, Thursday. Now we're gonna recapitulate everything by tomorrow from 8 maybe until 12. Everything.
Okay. No worries. We'll meet tomorrow then.
Yeah, yeah. Let me just send this recording.